So our next topic is measurement of insulation test. Measurement of insulation resistance. So here the insulation resistance of stator winding to earth frame, rotor winding to earth frame, and face-to-face winding, pedestal and bearing insulation resistance is measured using Megger. And the Megger reading for 15 seconds and 60 seconds are taken to find the polarization index, which is given by the formula here, I into R60 divided by I into I naught into R15. This R60 is nothing but resistance which is taken at 60 seconds and 15 seconds. And drying out shall be done if the insulation resistance is less than the specified values. The method of drying may be decided in consultation with the manufacturer. Next, coming to the measurement of DC winding resistance. So in measurement of DC winding resistance, the DC resistance of armature winding, field winding, and field discharge resistance are measured using the following methods, that is voltmeter ammeter method and reference field resistance, determination of irregularities of voltage waveforms, wave distortion factor, telephone harmonic factor, and line charging capacity. So coming to voltmeter ammeter method, in this the voltage applied across the winding and current through the winding are noted at the specified temperature. Then the resistance is calculated. This method is suitable for field resistance measurement. Built-in bridges like Wheatstone bridge and Kelvin's bridge are used to measure field resistance and armature resistance respectively. And as resistance is sensitive to temperature, temperature is also recorded and 3 to 5 readings are taken. Next, coming to reference field resistance. The resistance is normally measured at standstill condition by allowing the rotor being exposed to a sufficient time. This is for the entire rotor to reach the ambient temperature. This reference resistance helps in determining the field temperature during running by the method of variation in resistance. And when the reference resistance is measured, the current circulation through the field coil shall be low so as to not to cause any change in the temperature. Although it is preferable to obtain field resistance at standstill, but both the resistance and temperature can be determined more accurately by conducting the test when the generator is running near normal speed. Next, coming to determination of irregularities of voltage waveform. The wave deviation factor is an indication of the difference between the induced sine wave with an equivalent sine wave of the same frequency and magnitude. The waveform of the test voltage is recorded by an oscillograph. To permit adequate analysis, the maximum amplitude of the wave starting from 0 should be at least 32 millimeter and the distance for 1/2 cycle should be at least 38 millimeter. Even harmonics are produced, and for such an unsymmetrical wave, a complete cycle should be analyzed in certain machines. The maximum value of the deviation between two waves is designated by dE. Then the deviation factor is given by delta E divided by E ohm. That is nothing but the amplitude of equivalent sine wave. So it is given by the formula you can see here. And what is EJ? It is nothing but the instantaneous value of voltage wave at the jth point, whichever point it is. Next is wave distortion factor. The distortion factor of a voltage wave is the ratio of the RMS value of the residue after the elimination of the fundamental to the RMS value of the original wave. It is given by the formula where it is this is indicated as sum of the squares of the RMS value of all the components and RMS value of the voltage. The RMS value of harmonic content can be obtained using a filter that block only the fundamental component along with a dynamometer type calibrated AC voltmeter can be used. It can also be obtained by harmonic analyzer. In case of non-availability of special instruments, Fourier analysis can also be used. Next, coming to telephone harmonic factor. The telephone harmonic factor is given by this equation: 100 divided by VL, E1 square, lambda 1 square. So at till nth harmonic. So VL is nothing but the RMS value of the line to line terminal voltage of the machine, and En is RMS value of the nth harmonic in line to line voltage, and In is the weightage factor for frequency corresponding to nth harmonic. The telephone harmonic factor is the line to line terminal voltage and can be measured when the generator is running at rated speed at no load. The range of frequency shall cover all harmonics from rated frequency up to 5 kilohertz. Next is line charging capacity. The line charging capacity of a synchronous machine is its reactive power, which is given in kVAR. When operating at zero power factor, rated voltage, and with field current reduced to 0. When it is running as a motor and if coupled to a condensing steam turbine, it should be decoupled to prevent overheating of the turbine. When as a generator, the machine is run at normal speed and is connected to the load consisting of idle running over excited synchronous machine or to a bus, which may be considered as an infinite capacity voltage source. So next, coming to the open circuit test. So the open circuit characteristic of a synchronous machine, it is a curve showing the relationship between armature terminal voltage and the field excitation. Okay, it is a curve which is showing the relation between the terminal voltage and the field excitation current. The prime mover is run at rated speed, and the excitation is varied in steps and corresponding no load voltage is recorded. The characteristic curve may be plotted in per unit, where unit voltage and unit excitation corresponds to rated voltage and excitation current on the air gap line. And the open circuit characteristic usually represents the relation between the space fundamental component of the air gap flux and the MMF on the magnetic circuit, when the field winding consists of only the MMF source. Next, coming to sustained three-phase short circuit test. So in this test, the synchronous generator terminals are shorted through ammeters as seen in the figure. Okay, and the field current is gradually increased till the armature current reaches a maximum safe value, that is about 1.5 times the rated current. The relation between current and short circuit current is drawn and is known as a short circuit characteristic. In sustained short circuit test, the values of field current and armature current refers to the steady state values and are measured using indicating meters. Next, coming to short circuit ratio of a synchronous machine. It is defined as the ratio of field current required to obtain rated open circuit voltage to the field current required for obtaining rated sustained short circuit current when running at the rated speed, which is given by the formula here. The short circuit ratio is obtained from the data of no load test and sustained short circuit test conducted on the machine. which is as shown in figure. The impedance under steady state condition is known as synchronous impedance and is defined as the ratio of field current at rated armature current on sustained symmetrical short circuit to the field current at normal open circuit voltage on the air gap line. And the significance of short circuit test is given here. The low value of short circuit ratio increases and drop, whereas the armature current and the synchronous impedance drop increases, and the low value of short circuit ratio indicates smaller air gap and poor regulation, and synchronous power is inversely proportional to the synchronous impedance, which lead lower stability. Next, coming to the DC test. So DC test, it is the purpose of the DC test is to determine the armature resistance. A variable DC voltage source is connected between two stator terminals. The DC source is adjusted to provide approximately rated stator current, and the resistance between the two stator leads is determined from the voltmeter and ammeter reading, which is given here. If the stator is star connected, the per phase stator resistance is given by armature resistance is equal to DC resistance divided by 2, and if the stator is delta connected, it is given by this formula. And the determination of synchronous impedance, it is given here. For a particular field current, the internal voltage could be found from the open circuit test and the short circuit current, open circuit current and the short circuit current flow, and short circuit current flow could be found from the short circuit test. Then the synchronous reactance Xs could be obtained using the formula. And these are the conditions and the saturated condition of the synchronous impedance. Next, coming to the sudden three-phase short circuit test of generator. When an alternator is subjected to sudden short circuit, the current in all the three phases increases suddenly to a high value, that is 10 to 8 times full load current during the first quarter cycle. The flux crossing the air gap is large during first couple of cycles. The reactance during this period is least and the short circuit current is high. This reactance offered during subtransient period is called as subtransient reactance XD. The first few cycles are covered under subtransient state. After few cycles, the decrement in RMS value of short circuit current is less rapid than that during the first few cycles. This state is called as the transient state, and the reactance offered during this period is called as transient reactance XD. The circuit breaker contacts open during this period. Finally, the transient dies out and the current reaches a steady sinusoidal state called the steady state, and the reactance offered during this state is called as steady state reactance. Since the short circuit current lagged the voltage by 90 degrees, the reactance involved is direct axis reactance. The sudden three-phase short circuit test is conducted at rated speed and at desired no load voltage. The three phases are shorted suddenly. To measure the short circuit current, storage oscilloscope with proper probe multiplier is used. the terminal voltages of the machine, the excitation current, and the just before the short circuit. To obtain the quantities corresponding to the unsaturated state of the machine, this test is performed at several armature voltages, which is varying from 0.1 to 0.3 per unit rated value. To get the quantities corresponding to saturated state of the machine, the test is conducted with rated voltage and at the terminals of the machine before applying short circuit to the armature winding. If sudden short circuit test cannot be performed at rated armature voltage, it is recommendable that the test should be conducted at several armature voltages. To determine the machine quantities, oscillogram is taken of the armature current in each phase and the current in the excitation circuit. Short circuit is initiated by closing the circuit breaker and is removed by operating the opening the circuit breaker. So this is the figure and the waveform, it is being shown here. Oscillogram of current in the phase having 0 DC components, that is OA, OB and OC are the intercept of x-axis as shown. EA is equal to positive